So now we want to start talking about vectors, which is what we're going to really focus on the first few days. So we'll start with just looking at them in 2 dimensions, but then we can expand that out to 3 dimensions as well. So vectors are kind of a tricky thing to really pin down because when you look in different places, you'll find different definitions. Specifically, the way it's used in math versus the way it's used in physics and the way it's used in computer science can all look very different, but at the heart, they're really the same thing, which is why, we use the same word for all of those concepts. So if you've worked in the programming language R, for example, the default object that you're usually working with is a vector. And that can kind of be translated to what we're talking about here, even though it'll look very different. If you've taken introductory physics, you probably use vectors all the time, and that's close to the way we're going to be using them here. But if not, or if so, let's just get to the definition. So a vector is a quantity that has both magnitude and direction. Okay. So it's a quantity that has a direction. So we're going to represent it with an arrow, which, represents that direction. And it has a magnitude, meaning it has a length. So the way we'll represent this is if we're talking about the 2D plane. So if we have something like this, maybe we would have a vector which looks like this. So the length of the line will represent the magnitude, and then the direction it's going in, indicated by the arrow, indicates the direction. So this will be a vector with larger magnitude going in a different direction. This is a vector that's in the same direction as that first one, but with a larger magnitude because now it is longer. Okay. And you can also, we'll usually define a vector by defining the 2 points that it is connected to on the graph. So like this vector, for example, let's look at the smaller one. I'll go ahead and erase this one. This one, it kind of ends at the point 2, 2 and begins at the point 0, 0, right? So the way we might represent this vector is by taking the first point of each one and or taking the coordinates of each of these points and subtracting off the coordinates of the other point. So here it might look something like 2 minus 0, which is 2, and then 2 minus 0, which is 2. And then we use these like special brackets here to indicate that it's a vector. So this would be the vector 2, 2. Now when you represent it that way, you might notice that, okay, well, what if I make a vector that starts at 1, 1? Let me use a different color here. What if I make a vector that starts at 1, 1 and ends at 3, 3? Okay. Then that vector would also be called 2, 2. Right? Because you would do 3 minus 1, 3 minus 1. And you're right. There's not really a good way to distinguish between these two because they are both going in the same direction and they actually have the same magnitude. So a vector is a quantity that has both magnitude and direction. We can have several vectors with the same magnitude and direction. So it might be hard to distinguish between them. So in that case, we would call them equivalent vectors. Okay, and we'll get into this this notation and the naming in a little bit more. I'll write that down as a definition. So let's just kind of write down the things we have so far. So definition, 2 vectors with the same magnitude and direction are called equivalent vectors. Okay, so that's the definition for equivalent vectors. So getting into those 2 points for where a vector begins and ends. Okay, so I'll just draw it over here because it's getting kind of crowded over there. But just again, imagine this is in the plane here. So let's say this is like the point 1, 1, and maybe this is the point 2, 2 or something like that. Then this point right here is called the initial point. So this is where we imagine the vector starts, and then it's going in this direction. So this is what we call the terminal point. Okay. And there is a difference, you know, if you flip it around and now it's going in the other direction. So this vector would be represented as 1, 1. And if we flip it around and go in the other direction, say like the same points, that would be negative 1, negative 1. Right? So same magnitude, but going in the opposite direction. Okay. So we'll have an actual way to calculate that magnitude so that we can see that they are the same. So the way that we write vectors, so writing vectors, well, no surprise, we like to use the letter V as our first variable as a vector. Now, when we're handwriting it, it's common to put like an arrow over it, or often like this half arrow. So you can write like a full arrow over the point, but it's common just to write a half arrow, I think just out of convenience. So, you know, it's just a natural motion. You don't have to lift up the pen at all. But when you're typing it, this would be bolded. Okay. So typed, this would be bolded. Okay. So if you pick up any textbook or anything, or, you know, on the homework assignments, or quizzes or tests or whatever, I'll write them as bolded letters. Okay. So we could have V. If we have multiple vectors, maybe we like to use V1, V2, V3, etc. Maybe we like to use a different letter, W, maybe U is a common one. Things like that. We don't really use X as much in like calculus or like physics, but it is very common to use X as the vector in statistics. Okay, so you often will have X as a vector written as a bold face, and then it'll be equal to the data like X1, X2, up to Xn or something like that. That's super common. And we'll get into the different ways that you can write vectors, such as this one, but this might be something, you know, you've seen before if you're dealing with any kind of data. Another way to write vectors, sometimes we'll look at the points, like say that we want a vector between the points, which we call P, which is the point 1, 1, and Q, which is the point 8, 5. Okay, so this is a common way to assign a letter to point, so it's easier to talk about. So you don't have to say 1, 1 every time, you just say the point P, right? So if we wanted to write, denote the vector that's between PQ, we would write it like this. And this is often drawn with a full arrow, but you know, just sometimes, again, out of laziness or convenience or whatever you want to call it, you'll just kind of do that little half arrow. So this would be equal to the vector. Again, what we would do is we would take the coordinates of the terminal point and subtract the coordinates of the initial point. So we'd write it like this. So 7, 4 would be the vector. Now, when we kind of distill it into this information where we're just looking at the this gives us the magnitude and direction, but it again, there's a lot of equivalent vectors. So we kind of lose information by not referencing the initial and terminal points. So it's, there's, but the reason we do that is because oftentimes we don't really need that information, right? We just need an equivalent vector. So because of that, we can kind of take any vector and move it back to the origin, which is kind of what we're doing here with the way we're representing it. We're saying, okay, the vector between 1, 1, and 8, 5, that's equivalent to the vector between the origin and the point 7, 4, which is what we have written here. So that's kind of the common practice, is to take all of the vectors and center them, put the initial point on the origin, just so that they're easier to work with.